Okay, notice these are all, they look similar, right? These are all binomials. They've all got, they're quadratic equations, right? They've got x squareds and equals, right? Or quadratic expressions, right? Not equations. And we're going to try to rewrite these in factored form. We're going to factor them, okay? They look similar, but they're all a little bit different. The top one's probably the easiest. What can I do with the top one? GCF. Yeah, what is my GCF for the top one? Negative 7x. Very good. So then this is equal to negative 7x times what? And to find out, I mean, I can just think about it in terms of negative 7x times what is negative 7x squared, or I can just divide each term by negative 7x to see what's left over. How about from this first one? What do you get there? X. Okay, good. The negative 7s would cancel, and x squared over x is just x. What about the other term? Good. Okay, and that's it. That's all we can do. Okay, those are easy. Whenever we have a binomial, so two terms, and they both have a variable in them, it's a piece of cake. All you're going to do is just factor out the greatest common factor, and you're done. What about number 2? Is there a GCF here? 2. Yeah, I can take a 2 out, so I'm left with 2 times what? There you go. Okay, now, so that's small step, but now we're left with this other factor that has an x squared minus a number. How are we going to factor that one? You could use magic numbers. You know, you could you can always go back and do this, but it's extra work. We could write it as x squared plus 0x minus 64 and look for numbers that multiply to negative 64 and add to 0, right? But we could also think about this as being a pattern, right? If I have an x squared term minus a number, what's the only pattern that could fit? Well, okay, but what's just in general, in terms of A's and B's? Well, what is that? Come on now. Oh, A plus B times A minus B, right? It's the A squared minus B squared pattern, isn't it? It's the difference of squares. That's what we're trying to fit this to, if we can, right? Could I think of this as something, call it A squared, minus something else, call it B squared? If we can write it that way, oops, then we've got that simple pattern that we can fall back on. Right? So can we? Well, yeah, that's something squared minus something squared, isn't it? Mm-hmm. What is it? What's being squared here? Well, x. What's being squared here? 8. Okay, and then don't forget I've got my 2 out front. But what about the difference of squares part? What's A plus B going to be then? And A minus B? There you go. And we could have gotten that, couldn't we, just from our magic numbers. Numbers that multiply to negative 64 and add to 0 would have been positive 8, negative 8. Either way. But this is the easiest way. This pattern, we really want to know that pattern because we're going to need that pattern specifically when we get up to the next unit. We're going to come back to that one. So we can't, I know there's other ways, and you might be thinking, if I'm solving an equation like this, why not just isolate x? And you could, you're right. But when you get up to higher order polynomials, you got to use this trick. You got to use that pattern, okay? So we're done there. What about the next one? Any GCF we could factor out there?
No. Yes.
What do you think? Autumn, you got one? Oh, yeah. 3. Yeah, how do you know? Okay, and if you can divide them both by 3, you're right. And if you didn't, what if these were even bigger numbers? Remember the trick, you can add the digits. If I add the digits up, I get 9 and 12, and those are both numbers that are obviously divisible by 3. So 3 goes into both of those. So 3 would be our GCF. If we factor out a 3, what's left behind? Okay, so 9x squared. Okay, and that one, you might be tempted to think of that. Do you see a pattern there? Okay, 5 could be squared. And the first term is what quantity squared? 3x. So it looks like a sum of squares, doesn't it? Okay, but what's my sum of squares pattern? Not factorable, exactly. It's no pattern. You just leave it.
Which form?
So you'd leave it at this one, right? So yeah, you'd leave it there because you can't break apart a sum of squares. And so what's your thinking on that one then? How can you avoid going through all this work? Did I even need to do that stuff? No. I didn't, did I? I didn't need to do that stuff because even if, once I factor out the greatest common factor, even if I could break this up into a sum of squares, what's the point, right? So if I factor out the greatest common factor and then I've got an x squared term plus a number. Now if there were an x there, I could factor the x out, right? But if I have an x squared term plus a number, stop, you're done. Once you factor out the GCF, right? Okay, we're good? All right, so for today, here's the stuff we're gonna do today. Now there's some good news with this. So the stuff we're doing today is nothing new. We've done this stuff. In fact, we've done a harder version of this stuff than we're going to do now. If we go back, clear back to Unit 3, when we first talked about how to convert functions from standard form, ax squared plus bx plus c form, to vertex form, a times the quantity x minus h squared plus k, right? We ended up with a good trick for that. We ended up with a much easier way of doing it. We could just solve for a, h, and k and plug them in, right? Here, you know what? I think I gotta get this. Talk amongst yourself for just a minute. Okay. So, we originally, though, we used a process called completing the square. And we practiced it a little bit, and then we abandoned it for an easier one. Well, there's a reason I had you do it, because I knew we were coming back to it later. Let's just hit the highlights of this. So when we want to complete the square, in this case to solve an equation, here's really the starting place, right? We got to get it into the form x squared plus bx by itself on one side of the equation equals a number on the other side. Okay, so let's take an example like this one. Okay, if we were going to solve this, let's just say we're going to solve this the easiest way possible for a second. Okay, if you didn't know you were going to complete the square here, I just gave this problem to you, what would you do first? Subtract 20 is a good idea, because we want to get it equal to 0, right? We want to put it into standard form. So if I subtract 20, that's going to give me x squared minus 6x minus 11 equals 0. So it's in standard form. And then we can't isolate x, can we? Right? Because I don't have a single x I can point to. So that strategy is off the table. And where we're going with this, and I really want you to keep this in mind. At the end of the unit, we're going to get to a point where your job is going to be, given a quadratic equation, you're going to be able to pick the easiest way to solve it. In fact, we're going to have a whole assignment that's about nothing other than just, if I give you an equation, you have to tell me what's the best way to solve it. And I don't care about the solution, I want to know how to solve it, right? Then another assignment where you have to actually solve it. What's the first thing we would try? Factoring. Factoring is easy when you can do it, right? But are there magic numbers that multiply to negative 11 and add to negative 6? There are not, right? So factoring is off the table. So then we got to move on to another technique. We haven't talked about another way of doing this, right? Right now, the only two ways we've solved quadratic equations are by isolating x when we can't here, or by factoring, which we also can't do, right? So we gotta roll on to another method. Well, there's two other methods we're going to learn. One of them today is solving quadratics by completing the square. The second one we have yet to learn, that'll be for tomorrow, is applying the quadratic formula. You might remember doing that in Algebra 1. The good news is the quadratic formula always works, every time, and we'll get there tomorrow. But sometimes we can find easier ways to do it, right? So we can always go to that, but here's an example where it turns out that completing the square is going to be probably easier than the quadratic formula. When all's said and done, you can decide. If you want to just do the quadratic formula, you can, but I think you'll agree this is a pretty easy one to complete the square with. Okay, so to complete the square, we had to get the one side of the equation into the form x squared plus bx. So x squared plus some number times x. So what does that involve here? Add the 11 to the other side, right? I got to push the 11 to the other side. So that's going to give me x squared minus 6x. And I'm going to leave a space, like we did before when we're completing the square, equals 11. Okay? There's step one. We got it into this form, right? What next? Okay, so what's next is we're going to complete the square by taking half of b and squaring it, adding that number to both sides. So, what is half of b? What's b here?
6.
b equals negative 6. So b over 2 is negative 3. Okay, so then we want to add negative 3 squared to both sides. Well, what is negative 3 squared? 9. So I'm just going to add 9 to both sides. Okay, on the right side we just get 20. Now why are we doing this? Well, because the next step is, after we add half of b to both sides, is we're just going to factor. Right? Okay, well, what are the magic numbers that multiply to positive 9 and add to negative 6? What are they? Multiply to positive 9 and add to negative 6? Negative 3 and negative 3. It's always going to be that way, right? It's always going to end up, when we factor this thing, we know we're always going to get x plus half of b squared every time. Okay, now we're actually done completing the square. We're not done with the problem. We're just done completing the square. Right? Why did we complete the square? What's the advantage of this compared to what we started with?
Wait a minute. That's the same equation that we started with. And then we did a bunch of work, and then we got back. Right?
Oh, you're right. Up here, you mean?
Yeah.
No, it is. You're right. You're right. And that's, we could have, you're right, in this one. But it's not always going to be that way. You're right. We lucked out this time, yeah. But what's the advantage of this equation compared to what we started with? And I'm trying to solve it, right? 1x. Yeah, look at that. There's a single x that we can point to, so we can isolate it, right? And it's easy to isolate. What are the only two things I got to do to isolate it? Square root first, good. So if we square root both sides, that's going to cancel the square. So that gives me x minus 3. Now if I square root both sides of an equation, what do I always have to put before I even think of anything? Plus or minus, good. So I get plus or minus the square root of 20. Well, we can make a little factor tree for 20, and what do we get? 2 and 10, and 10 breaks up into 2 and 5. Okay, so we get a couple of 2's and single 5, right? So I get plus or minus 2 times the square root of 5. And what's the last thing I have to do to get the x by itself? Add 3. Where do I put the 3? Yeah, good, in front of the plus or minus. So we add 3, and there are my answers. I get 2 and 1, don't I? I get x equals 3 plus or minus 2 radical 5. So in Moodle, how would I write my answers if that's my Moodle answer box? 3 plus 2 radical 5, comma, 3 minus 2 radical 5. Okay?
So did we square, x minus 3 squared? I mean, not squared, did we, what's that called again?
Square root?
Yes.
Yes, that's what we did.
Okay, to get rid of the.
To get rid of the square. Right, so the two steps we had to do to isolate the x were, because we're reversing order of operations. So the first thing we had to do was square root to get rid of the squared, and then finally, now we get to the parentheses and we add 3. Okay? So you see the strategy then. Completing the square, all it really does, it's a simple thing to do, but what it does is it rewrites the equation. It kind of configures it differently. So instead of looking like an equation that has an x squared and an x term, we write it in a way that only has a single x that we can isolate. That's the whole point of completing the square. It's why it's a good strategy. Now, by the end of the lesson today, you're going to be able to tell me, when do I want to do this, when is it really easy to do, and when do I avoid it, when is it hard. Okay? Let's try another one though. Try this one. Solve by completing the square. Okay? So are there numbers, first of all, that multiply to positive 56 and add to negative 18? I don't think so. 7 and 8 would be 15, and then I really don't think so. No, it's not going to work. Not going to work. You're going to get 14. And, actually, you could. 14 and 4.
Yeah.
It would work. Okay. So this is one that we could do by factoring. Okay. But let's not. Let's solve it by completing the square to get some more practice. Okay. So we're starting off in standard form. What would step 1 be for us if we're going to solve this by completing the square? Subtract 56, right? Because remember, step 1 is going to be, we got to get it in that form, right? So step 1, we're going to subtract 56, and we get x squared minus 18x, leave a space, because you know you're going to add a number to both sides, equals negative 56. Okay, what is b in this equation? So what is b over 2? Negative 9, right? So what number then, Mehalani, what number are we going to add to both sides? 81, exactly. Good, we're going to add half of b squared. Good, negative 9 squared equals 81. So we're going to add 81 to both sides. There's step 1, right? I guess that's really step 1 and 2, isn't it? I mean, we wouldn't need to break it down to steps. We're getting this. Okay, so now on the right side, what do we end up with, Gabe? Negative 56 plus 81. Mm, 25. There you go. So what about the left side? I'm going to factor it, right? Dominic, what are my magic numbers going to be? Negative 9, and we know that. It's always going to be half of b, right? So we're going to get x minus 9 squared. X minus 9 times x minus 9, right? Okay, so we're done completing the square. Now what? Joseph, what's next? How am I going to get that x by itself? Square root. Good. So next step is we're going to square root both sides, which is going to cancel the squared. So we get x minus 9 equals, okay, plus or minus. There we go. Plus or minus 5. And then last step, add 9. There you go. And so we get both answers in one. We get x equals 9 plus or minus 5. So how would we put that in Moodle? Okay, but 9 plus 5, that's not simplified. What is 9 plus 5? 14. What's 9 minus 5? 14 and 4 are my two solutions, aren't they? Right? Okay? Good stuff. All right. So what about this one?
Well, you see, it's already in.
Kind of, almost. What's the one thing I got to do?
So you want to be,
Divide by 2. Yeah, because I need x squared, not 2x squared, right? So this is one where I could divide each side through by 2. And if I do that, on the left side, what do I get? Okay, I'll leave a space, equals. Okay? And once again, I could put this in standard form, and I think I could actually factor this one. But let's not. Let's just do it this way. Okay, let's do it by completing the square. Just about as easy anyway. So what's b in this case, Mackenzie? But we got to look at this equation here, right?
It'd be -8.
-8, good. And we want to use the equation where we've got it as x squared plus bx, right? So b is -8, so then what's b over 2? I'm putting a circle around that because that's going to be my magic number, isn't it? Right? So what do I add to both sides then?
16.
Good, I'm adding -4 squared, right? So I'm adding 16 to both sides. So then on the right side, I'm just getting a 1. On the left side, what am I getting? I'm just going to factor it. X minus 4 times x minus 4, so x minus 4 squared. Piece of cake now, right? Square root both sides. And what happens if I square root both sides? I get x minus 4 equals plus or minus square root of 1 is 1. And so then last step, add 4. And so there are my two answers. X equals 4 plus or minus 1. If I take the plus, what do I get? 5. If I take the minus, what do I get? Good. And you see, we could have, you see that we could have, up here at the beginning, I mean, we really could have factored this, couldn't we? Right? Way back up here when we had x squared minus 8x equals -15, we could have added 15 to both sides and gotten x squared minus 8x plus 15 equals 0. And what are my magic numbers? We multiply to positive 15 and add to -8. -5, -3. So that gives us our solutions. X equals 5, 4, x equals 3. That's easier, isn't it, to factor it? When it works, it's easy. You want to do it. Okay? All right, so last issue then. Now let's talk about some that we don't want to complete the square with. What would we do here probably? Subtract 1 and subtract 8x, right, to put it in standard form. Okay, if I do all that stuff, I get x squared plus 9x plus 4 equals 0. Okay, it doesn't factor, right? But if I try to complete the square with this, you tell me what's the problem. What's b? Okay, so what's half of b? Well, it was 9/2, right? And then 9/2 squared is going to be 81/4. You see the problem? We're going to have a bunch of fractions to deal with, right? So this is one that we would probably just skip completing the square on, right? And why is it? How could we look at this stage right here and say, aha, forget completing the square? And how do you know it's going to be a fraction? Because b is odd. Yeah, look at that. Right? That's the problem with that one, isn't it? So we skip it. So what about this one?
Wait, so,
Mhm. Oh, well, I mean, I'm not gonna, so here's the good news. I'm not gonna give you any to-do on this assignment that you would do a different way if you could, because there's no point. You're just gonna do them a different way when you can, right? So on this assignment, you won't get them, but eventually on Moodle, when it says solve this quadratic equation using any method, you're just not gonna use completing the square, are you? Right, and move on to something else, and that something else would be the quadratic number. Okay? What about this one? What are the two things that are wrong with it right now that I'd have to fix to complete the square? Divide by 4, okay? I guess it's only one thing I have to do, it's divide by 4, right? So if I divide both sides by 4, the left side looks great. Look, I end up with x squared minus 2x. Now what's the problem though? There's a fraction on that side, right? So we got a fraction in there again. So this time we're not going to deal with it because I end up with a fraction on the right side before I complete the square. And so we would just choose not to complete the square, right? Okay, last one. What about this guy? This is pretty obvious. Yeah, we got a problem here, don't we? When I divide by 3, look what's going to happen. When I divide both sides by 3, and I could even subtract the 8 to the other side. So I get 3x squared plus 10x equals negative 8. I divide by 3, and look what happens. I get x squared plus 10/3 x. Already we know we're not going to do this, because if b is a fraction, half of b is going to be another fraction, right? See my point? So here's another example of one that we would not choose to complete the square with. Okay? All right, good stuff.